Good morning. It is May 4th, 2020. Today I can find missing arcs and angles of a circle by adding the 360, 1/80th given a diameter, central angle equals the intercepted arc, and inscribed angles equal half of the intercepted arc. This is the first lesson in the circles unit, and there's a lot of little rules in this unit. We're going to talk about 4 of them in this lesson, and each lesson is going to pretty much be 1 or 2 more. So let's kind of discover some of these things. Now the full arcs of a circle, oops, that's not what I wanted. The full arcs of a circle add to 360. Basically, if you walk yourself in a full circle, you've gone 360 degrees. So the full arcs of a circle is 360 degrees. Now if I draw one of these in, which we talked about in the last unit, a line segment that goes through the center is a diameter. Since the diameter cuts a circle in half, each half is half of 360. So this green arc is 180, and this blue arc is also 180. So that's the first 2 little things we're talking about. The full arcs of a circle add to 360. If a diameter is drawn, then each half adds to 180. All right. Now, central angles. A central angle is an angle that center whose vertex is at the center of the circle. So I'm going to draw my best to make one of these in here. So the intercepted arc is the arc between the points that are hit on the circle. So I tried to draw this so that this arc is 1/4 of the circle. Hopefully we agree that this arc is 1/4 of the circle, which means it's 1/4 of 360, which would make it 90. Look at the angle. It's a right angle. What's the relationship between the central angle and the intercepted arc? They're the same. Central angles equal the intercepted arc. So if the vertex is at the center of the circle, the angle is equal to the intercepted arc. And the last rule we're going to talk about today is an inscribed angle. Now an inscribed angle, let me just redraw that. An inscribed angle is an angle whose vertex is on the circle. Not at the center of the circle, but on the circle. Now I tried to make this arc half of the circle, which would make this arc 180, and this angle here is 90. So what's the relationship? Well, they're not equal, but the inscribed angle is half of the intercepted arc. 90 is half of 180. The inscribed angle is always half of the intercepted arc. So let's sum up what we've talked about. The full arcs of a circle add to 360. If a diameter is drawn, then each half is 180. A central angle is equal to the intercepted arc. An inscribed angle is half of the intercepted arc. So let's do some examples. Here are the notes for this. This is in the front of the packet. Everything we kind of just talked about is here. It shows that the full arcs, if you add these all up, add to 360. This diameter is drawn, so these 2 add to 180. 60 and 120 is 180. A central angle is the same as the intercepted arc. 100 is equal to 100. And the inscribed angle, if the vertex is on the circle, it's half of the intercepted arc. So number 1, the measure of arc CA is 80. The measure of arc AB is 150. And it's asking for arc BC. So I'm always going to put an X on what I'm trying to find. Well, we're dealing with the arcs of a circle. And these 3 arcs together make up the full circle. I know that the arcs of a circle add to 360, so I can add the pieces of the arc to equal 360. If you're given expressions for all the pieces of the full arc, you add them to 360 because the arcs of a circle add to 360. From here, I do the algebra, and I get 130. Again, the full arcs of a circle add 360. Number 2, arc DC equals 75. It's asking for arc CB. Now, I don't have the full arcs of the circle because I don't have any expressions for this over here. However, I do see that a diameter is drawn. And if a diameter is drawn, then each half adds to 180. So 75 plus x equals 180. If a diameter is drawn, each half adds to 180. I do the algebra, and I get 105. Arc DG is 130. Find the measure of angle DOG. Well, now I'm dealing with angles. What type of angle is angle DOG? Well, since its vertex is at the center, it's a central angle. And a central angle is equal to the intercepted arc. So, if the intercepted arc is 130, then the central angle is also 130. When the vertex is at the center of the circle, it's equal to the intercepted arc. The math itself is simple. It's just you need to know the rules. You need to look to see where the vertex is. If the vertex is at the center of the circle, it's equal to the intercepted arc. Number 4, if angle BOY is 87, it's asking for the measure of arc BY. Well, what type of angle is it? It's a central angle. And again, a central angle is equal to the intercepted arc. So, what do you think arc BY is? I'll give you 5 seconds. Since the central angle is equal to the intercepted arc, they're the same. The intercepted arc is 87. There's a little twist on number 5, so let's deal with that. Again, I see a central angle since the vertex is at the center. So if the vertex is at the center, central arc is equal to the intercepted arc. However, it's not asking for arc AR. It's not asking for the red arc. It's asking for the green arc. Well, what's the relationship between the red arc and the green arc? Well, together, they make a full circle. So, since together they make a full circle, they must add to 360. And that would be 258. So you can incorporate multiple rules within the same problem. Number 6, is the vertex at the center of the circle? No, it's on the circle. When it's on the circle, it's called an inscribed angle. And the rule for inscribed, it's not equal to the intercepted arc, it's equal to half of the intercepted arc. So, if the inscribed angle is 35, then the intercepted arc must be, 70. The angle is half of the arc, so the arc is double the angle. Similarly, for number 7, again, it's asking for an inscribed angle since the vertex is on the circle. And again, an inscribed angle is equal to half of the intercepted arc. So, half of 170 is 85. And that's it. What have I got? I got 2 problems left for you. You know what? Let's just go through the whole thing together. It's asking for two things here. It's giving me this. Well, it's giving me an angle. What type of angle is that? Where's the vertex? The vertex is on the circle, so it's an inscribed angle. And we know that the inscribed angle is equal to half of the intercepted arc. So if the inscribed angle is 27, then the intercepted arc is 54. Now it's asking for this. What type of angle is this? That's a central angle. Central angle is equal to the intercepted arc. So if this is 54, then this is 54, so x and y are both 54. And finally, angle TRI is 4x plus 6. Arc TI is 84, and it's asking for the value of x. Well, what type of angle do I have here? It's on the circle, so it's inscribed. Inscribed angle is half of the intercepted arc. So the inscribed angle is 4x plus 6. It's half of the intercepted arc, which is 84. That's how I set it up. All right, the inscribed angle is half of the intercepted arc. So 1/2 times 84 is 42. I do the algebra. X is 9. That's it. I'm not going to quiz you on this lesson. It's just a quick little intro. You're going to have, in fact, you know what? I think tomorrow's quiz is going to incorporate a couple of this as well. So you're off the hook for today. I know I posted this late, so you're not going to have any assignments from this. Hopefully you feel comfortable with everything. Again, the full arcs of a circle add to 360. The diameter is drawn. Each half adds to 180. Central angle, if the vertex is at the center, is equal to the intercepted arc. Inscribed angle, when the vertex is on the circle, is half of the intercepted arc. Any questions, reach out to me and remind, and enjoy the rest of your day.